Hello, everybody. Today we're covering assemblies. And what we're going to do, we're going to design two components first, kind of using our previous knowledge that we've learned in xDesign. And we're going to put those into an assembly and use them to make a working scissor lift. Or if you're a cartoon fan, the little boxing glove thing that springs out and punches someone. So anyway, let's start with what are assemblies. Assemblies are a way to bring multiple components or parts together in one document. And then we can take those individual parts and define some parameters around how they will fit and interact with each other. And the way we do that is defining one or more mate relationship. We're going to usually need more than one, but we'll get into that. And just as sketches have a number of different constraints, if you remember, we had a number of ways we could constrain different elements of a sketch to each other. Assemblies do that, but they do that with different types of mates. So we'll go through a couple of slides and explain a few of the mates available. I probably missed a few. They're very context sensitive, so they don't always pop up if you don't have it. But at least this will give you an idea of where to get started. And I'll also give an example of what kind of situation we'd use each of those mates in. So the first mate we'll talk about is concentric. You can see it's kind of denoted by two circles that are concentric to each other. And that's usually if you have two circular or cylindrical components and you want them to be concentric together, hence the name concentric. And a good example of that is if we're putting a bolt into a hole or a pin into a hole, or basically anything round into a hole, that would be a concentric type mate. And it only will make it concentric to that hole. It won't define the height of it. So you can still, even though it's concentric to the hole, you can still lift it up and down and in and out of the hole that way, because it's only defining one part of that mate relationship, which is the concentric part. Perpendicular mates, kind of exactly as it sounds again. Picture if you had like a wall and a base plate. If you made the wall perpendicular to the base plate, it would be at 90 degrees relative to the base plate. And that's kind of important because if you're to move your base plate and angle your base plate, the perpendicular wall would stay perpendicular to that base plate, so it would automatically rotate with it. Parallel is kind of opposite to perpendicular, where if you had kind of like, say on the Elegoo robot, we've got the top and bottom mounting plates. Those two plates are parallel to each other. A useful one is a tangent mate. If you have some kind of circular, cylindrical, elliptical component, you can make that tangent with another face or plane. A good example for that is if you had a wheel of your robot and you put it down on a table, that wheel will be tangent to the table. So only one part of the wheel is going to touch the table, and that's the tangent part. You can get some really neat things with like kind of ellipses and cam-shaped parts. You can even use tangent mates to start to model how gears work and gearbox. Coincident is, as you can see by the little drawing on the left, there's a line and one or more parts that are coincident touching that line. They can be on the same side or opposite sides. And maybe I'll just touch on briefly, if we had that concentric mate for the bolt, and we wanted to make sure that the bolt head didn't pass through the surface of the hole, we would make the bottom of the bolt head coincident with the surface of the bolt hole, I guess you would say. And then that would be a more defined mate relationship using two to define one part. Distance, again, we can specify the distance between two faces. And often we don't want to do this to define the distance, but we'll use it to set a max and min and use it to set a max min travel. For example, if we had a pneumatic piston, we could set a max min travel of the inner arm of the piston with respect to the outer arm. So we can't pull the arm of the piston completely out, and we can't push it all the way through the other side. And same goes for angle. With angle, we often use that for the limits, so we can't overextend, hyperextend, or collapse something too far. So what we'll do in the live exercise, we'll make a little arm plate with 3 holes in it and a pin, and we'll assemble those together and make kind of a scissor lift. Or I don't know if you watch Looney Tunes cartoons, they always tend to put a boxing glove on one of these, and when you squeeze the two elements together, it flies across the room. But it's also quite useful for lifting things. A small amount of motion on the bottom can, especially if you cascade these up, can make a very large rise, a very large lift. So what I'll do now is I'll run through a really quick overview of what we're going to cover in the live demo, and we'll go into a lot more detail in the live demo, but this is kind of just a heads up to get yourself oriented to what we're going to cover. We'll take the components we put in, and xDesign is very useful in that when you select two, if you remember how we select more than one component, we control select it. So if we can control select two or more cylindrical surfaces, it'll pop up the context sensitive dialog with a number of the mate options that are available there. You can see most of the options there are the ones we talked about. So the concentric mate is there. So if we were to click on that concentric mate, it would make them concentric and turn green, saying that, well, we've got a concentric mate now, but as you can see, the pin is still floating above it. So we can group more than one mate together to get our desired motion. So the way we do that is we hit apply and continue. And after we hit apply and continue, it'll bring up a dialog to bring the next mate connector up. And we can also now select the bottom face of the pin and the face of the arm and select the coincident mate. And then instead of doing apply and continue, we can just hit the checkbox right there and close that out automatically instead of doing continue, because that's all the mates we need for that part. And then what you'll see, I hope you can't see this dialog that's popped up on my screen. What you see is in the design manager, we've got a new section down here now called mates. And what it's done is it realizes the concentric mate and the coincident mate work together to make a revolute mate. And the revolute mate is, if you picture kind of a bolt turning in a hole, and it can spin but not rise up and down, that would be a revolute mate. So let's kind of group those together. Okay. So now if we were to insert a second arm, we get, there's a couple different ways of inserting it. We'll do maybe a little more lengthy way of doing it, but it's a little more standard with traditional CAD. So we're going to put a second arm in, and we can mate it just as we did the first one. We'll be able to drag those around and cascade a bunch of those arms together to get the scissor lift we talked about. So let's go and do a live demo now. I'm going to switch here. I already have xDesign started. It's on the standard splash screen. So I'll click out of that. We're in 3D Experience. Hit my compass. We will go into xDesign. And again, as soon as xDesign fires up, I'm going to close this panel over here with the navigation panel to get into full screen mode. Gives us a little more real estate to play around with. Okay, so we're going to make a new component, and let's call this an S arm for scissor arm. Let's delete everything here. S arm, and we can put it in whatever location we want. You can see now that our 3D spaces are, we're able to pop down here. So I'll put it in my share test, and we'll make a component called an S arm. Now, with any sketch, well, hopefully you've watched the sketch workshops before, we have an idea how to sketch in xDesign. With any sketch, we have to start with a base plane. And what we'll do now, we'll use a new sketch feature that we probably not used before, is a Centerline Slot. It's kind of really useful for kind of making a slot with a diameter. And I just arbitrarily clicked on the front plane. I'm going to press the N key to make that normal. And what we're going to do, we're going to start point and end point of our slot. So I'll do that as the start. If I drag it, I'm moving around, and I'm going to hover so I get the H, which means this will be horizontal. So it'll be defined horizontal. And now I've defined the length of it, and I can kind of give it a thickness too. So you can see that's a pretty cool feature where now we get this, automatically get this closed circular. Often for a slot, say if you had a screw you're going to put in, you want the screw to be able to slide back and forth in the slot. That's what it's useful for. But as with most CAD features, we can use it for something that's not exactly designed for. So we'll use it for this arm. So what we can do now is we'll click on the center line. We'll give it a dimension. And we click on it, we can say whatever we want. Let's do it 75 millimeters. Well, now to fully define it, we'll also need to give it a radius here. Actually, 6 looks not bad. Should we do 6? 5, let's make it 6. Make the arm a little more beefy. Okay, so now that's turned black, so that's a fully defined sketch, which is what we want. So what I'm going to do now, we want to put the 3 circles in it. So let me zoom in a little bit here. You see what we're doing. So make a circle about that big there. We want one in the center. And you can see we've already got a midpoint in here, the center line. So it makes it super easy. We don't even really have to dimension anything or think. Now, as I move this circle and drag it to different diameters, suddenly you see it turn blue and kind of snap to something. Right there, I've snapped to that blue line so that inner circle will be tangent. You can see a tangent mate highlighted just below my cursor here. It'll be tangent with the edge of that slot. And if I click down here, you can see the other circle turn blue, or cyan, I guess would be the color. So if I do that, those two circles will be equal. I'll do the same thing here. I'll size it. So I've kind of just I've automatically made 3 relationships between those circles without really lifting my mouse or going any extra work. And you'll find a lot of those shortcuts are available in CAD. So let's make this even 5 millimeters. Now, when I change this, you'll see all of them will change automatically because they're all set to equal. So that's kind of what we're looking at for the arm. So I'm going to rotate it a little bit. And I have to move this a little bit out of the way. And from here, we're going to go into features. We'll do our extrude. Think about it for a sec. And 35 millimeters is way too big. Let's make it more like 5 millimeters. So we're 5 millimeters thick. And that's kind of what I was hoping for. It kind of looks like the little arm make great for a scissor lift. So what we'll do now is we're going to hit save. And this will save the component. And this will allow us to use it in this model, another model, whatever we want. So this is now saved into our workspace. So we can do now, anytime you see an asterisk up here, it's going to usually mean new. So click on this and we'll make a new component. And we call this was the scissor lift we're working on, so we'll call this an S pin. We have the S arm, make an S pin, we'll hit start. And there's a little less clunky ways to do it, but this is kind of a good way to introduce you into it. We're working on the components individually, separately. We could also work on them together on the same part and not have to remember what the diameters were and such. So I clicked on the sketch on the context sensitive dialog. We'll make a circle. We'll also make this on the XY plane here, the top plane. I'm going to hit N to get normal to it, so we're looking at it from the top. And we might as well pick something for the origin, snap it on there. We'll snap it to the center. And we now have our circle. And let's make this 5 millimeters because we knew that the hole we made was 5 millimeters. So I hit 5. And now here's your skill testing question. How high do we want to extrude it? So we're going to click features and extrude. We know the arm is 5 millimeters thick. So we do 5 millimeters right, or do we want to do it 10 because we're going through 2 arms? Well, let's do it 10. We have a top arm and a bottom arm. Okay, so now we can hit save on that as well. And that'll be saved to our workspace. And xDesign doesn't really have any kind of preconceived notion about what a part or an assembly or anything is. It's all kind of the same. And like you can see, it says create a new component if I hover a new. So we're going to create a component, but this time it's going to be the lift assembly. So let's call this S lift. We get the S arm, the S pin, and the S lift. Okay, so we got a new component, and you can see it looks exactly the same, even though in the back of our minds we know we're going to do an assembly. So from here, we'll click on the assembly tab here, and we've got a whole bunch of new tools down here that we've not used before. And these are the ones we're interested in right here. So this is insert new component or insert existing component. And we've already made it. So let's do an existing one, and we can pick something we've already drawn. We could kind of navigate through. You can see I've got quite a few different components here. We can navigate through, or we can use this little search dialog here to call it S arm. And it's kind of important that we pick the arm first, and I'll get into that in a second. Usually it shows a preview here, but because we just created it, the preview is not quite available yet. Within a minute or two, you'll be able to see a preview. So I'm going to click on it once. I'm not going to double click and go down here and say, okay. And give it a sec. And there we are. So now you can see our arm is inserted into this workspace. And if we look over at our design manager, there's something we've probably not seen before, this little anchor shape here. What that anchor means, it means it's a fixed component. So Usually the very first component you insert into your assembly, you want it to be fixed. So if I try and drag this, I can't click on it and drag it anywhere because it's fixed in space. It can't move no matter what. If I was to go over here to the design manager and right click, you can see the anchor is here. And if I was to click that anchor, it would float and I would be able to move it wherever I want. Okay, so we've got our arm. So now let's insert our pin. The same kind of way, we can go back to this dialog. We can insert as many components as we want into this new document. So we'll do spin, we'll search for that. I think I call it spin. I call it spin. Okay, so it didn't show for some reason. So what we'll do, we'll close out the search dialog. We will go where that's still not working. So I'm going to close this out and try. Okay, how do we get out of this in xDesign? Okay, so I hit the little X up there to close out of that. So let's try that again. So we'll insert, and maybe I called it something different. Maybe xDesign is just being difficult. So let's go to the what, where. Okay. Engineering workspace. Yeah, I can't seem to find where the pin is. So what I'll do, I'll just manually look through. Oh, here it is, S pin. So for some reason I couldn't find it the very first time we tried to search it. It's there now. So I'm gonna, again, I've clicked it once, it's got the checkbox there. So I'm gonna hit OK. And I find that with xDesign, sometimes stuff doesn't quite work the first try. Go back and try it again, and it seems to work not too bad. So you can see now this pin, it came in at the origin up here. You can see the little 3 reference axes as the origin. And I'm able to drag it around this time, because if you look, because the very first part I inserted was fixed, this one is not. So this, without the anchor, means it can float. So as we talked about in the prelude, I'm going to use the control key to select more than one component. So I'm going to make sure I pick the cylindrical face of this, hold down control and pick the cylindrical face of this. Now when I let go of control, the dialog will, context sensitive dialog will pop up. I'll hit the concentric mate and it pops in. Okay, so it's in the hole. I'll hit apply and continue. And what I'm going to do, I'm going to rotate down here. I'll pick this surface and this surface. And already it kind of knows, it's pretty smart, it knows what we're doing. It automatically defaulted to the coincident mate because it thinks we want that to be a revolute. So I'll hit OK. Now if we look, that pin is now mated to this. And if I was to unfix this base arm and move it around, the pin would follow it now. And if I try and drag this pin, I can't drag it, but you can see our axis system is spinning because we've not fixed a rotation yet. So the only thing this pin can do is spin, which is kind of exactly what we're looking for. So the next thing we can do is put a new arm in, and there's a really quick way to do that in xDesign. If I go over here to the design manager, hold down the control key, I'm going to drag that arm in, and I'll just move it around a little bit and wait. It's best if you wait till it appears like that. Now when I let go, the arm will be placed. If I didn't wait till it was appeared, it would be placed at the origin. It would be overlapped on top of this one. It's a little harder to see. Okay, so as you can imagine, what we want to do next, I'm going to hold control and click this cylindrical face, control this cylindrical face. I let go. Now I can make another concentric mate. They move, but I want to also constrain the height. So apply and continue, and I'm going to mate the top of this pin with the top of this. And I'm done. So instead of hitting apply and continue, I'm just going to hit the checkbox. The two are aligned perfectly, but now if I grab this top pin, which is not fixed, or this top arm, I can move it around. Can't move it up or down, but that's kind of exactly what we want. So what we're going to do next is make the second stage. And for that, we're going to need a pin and a pin for the pivot. So I'll take and do what I did before. I'm going to take a pin. I'll wait till it appears. Let go. I might as well do them all at once. You can do them individually, but let's do it this way. In any of these, I'll put this in the middle somewhere. We need 2 arms. This is just one example of how to use mates. This workshop isn't intended to be like a full, complete explanation of all assemblies and mates. It's just kind of one example with the intent that it gets you in. You just get enough information to start playing around and having some fun with it. Okay, so one of the things we can do now is we don't necessarily have to do just two surfaces to mate with at once. We can do them all. So I want to mate this pin with this. And you have to make sure you pick the right surface too. Sometimes you can see how you might pick just this edge here, which I had done first, but I go right in the inside, and you can see the walls light up as well. So that's what we want. I just want to mate it with that pin. So now if I let go, I've got these 3 cylindrical surfaces. And if I click concentric, they will all line up. So now you got to think a little bit here. We want to make the scissor lift. So we want this pin to be below this arm, so it'll be on the same level as this one. So the best way to do that is let's mate. Can we see the top of that pin? Oh, so let's hit apply and continue first. I always forget that. So let's see if we can get a view on the top of that pin right there. So I'm going to click that and click this. Now you can see, again, it kind of figured out what we're doing. It defaulted to the coincident mate, and that's what we want. We want the pin going through. So I'm going to apply, continue that. Now what we'll do is we will mate. Sometimes you got to hunt around a little bit to make sure you don't select the planes or other features in your sketch. As you saw me doing there. Okay, and that is now mated to the bottom, just like we wanted. So again, I'll hit, also if we accidentally hit apply and continue, it brings up another mate dialog box. All we need to do is hit X because we're done. The other one will still be mated. So now if we grab this one, this guy will kind of move in combination with the other. So we can do this a lot quicker now that we know what we're doing. We're going to mate the 3 things, this one, and this one. I let go of control. Okay, so the concentric mate didn't pop up, so you can see this plane was selected as well. So it already knew that we can't do concentric mate, so it was just a little bit of sloppy clicking, so we'll try that again. Let's press escape and we can go back, not to worry. I let go, now we get the concentric mate. So they are concentric, a little bit of thinking again. This time we do want this arm on top of this arm. That means it'll pass over top the other one. Okay, so we'll apply and continue. That means this pin will be made with the top of this one. And by default, it knew the right mate. So we'll apply and continue, and we'll go down, do this face and this face. And we're done with that one. So we're done. So now we almost have our scissors lift built pretty quick. But before we do that, we had talked about using other mates to kind of constrain something. So let's try another type of mate here. So we'll click on this face, and hold down Control and click on this face. So we have 2 faces that are rotating with respect to each other. So what I like to do is click this angle mate. Okay, you can see now, for angle mate, we've got these 2 faces, and right now they're at 63 degrees with respect to each other. There's a little arrow here for angle limits. So I'm going to click on that, and right now it gives us a minimum and a maximum. So let's set our maximum to about, I don't know, maybe 150 degrees. Oop, 250, that's a lot. 150. Let's set our min to about 30. And I'll just click away from it, and I'll go back and think, and it knows that the 63 is between these, so it's happy. So I'm gonna hit OK. So now these two mate, these two, you can see down here, we now have an angle mate over in our feature tree. So if I grab this and start dragging this guy now, I can't go any further than that, because what we've basically done is we've stopped our scissor at 30 degrees. And if we go all the way out here, we've stopped it at, I think it's at 150 or something like that. So that's going to stop our scissor lift from slamming into itself, which is good. And there is what we're about to do now. We can make this thing kind of flip inside out, which is a bit of a pain. We can work around it, but I'm going to position them reasonably close to each other so we don't have to worry about that. And we'll insert this pin, which we know we can just pick these three surfaces, all the three cylinders, let go, make that coincident. And our sketch is starting to get a little more defined now, so we might not need, or not might not, we won't need to define everything this time, because the arm already can't really pop off based on some previous constraints we did. So we will only need to find this one relationship with this pin to make it coincident. Now, if we hit OK, this arm can't lift up, so it would be redundant to make this and this coincident, because there's no way it cannot be, because their coincident mate is here. So these two can't separate no matter what we do. So now let's take a look at some of the kind of more complex animations you can get with 3D CAD. You can see the only way for this to work now is for them to work kind of in tandem. So even though I'm only grabbing this bottom arm and moving that, they're both moving as an assembly, and they're figuring it out. So you can see also every part we've inserted has its axis turned on. We can turn that off and disable it. I'll just leave it on for now because it's a little bit easier. But anyways, if you want, you could cascade more of these to make the scissors lift go higher. And what it ends up being is, with a little bit of motion in this way, you can see how much higher the scissor lift moves. Ideally, what we want to do is make these two, let's say, tangent to a base plate, or do something to constrain these to a table and float this arm and get our constraint a little more complex that way. But I think this gives the idea. So I think that's a quick introduction to mates that will allow you to go on. If there's some interest, what we have, someone has created the Elegoo car, the Elegoo robot car, in a platform called GrabCAD. And with xDesign, we can't import, even though it's made by SolidWorks, we can't directly import SolidWorks designs into xDesign, but we can import that as kind of like bodies. So we can pull it in, and it won't be exact CAD design, but we can still do quite a bit with it. And we can use that Elegoo car to start assembling some of our own components onto it, and kind of test how our components will fit with the Elegoo car. If you're working on a manipulator or an arm or something like that, we can start looking at that. So at that, I think that's about what we wanted to cover for this. And I'd say if there's any other topics you want to cover, feel free to go on to Discord and just say what it is. I think we've covered a lot of the topics so far to kind of give you a taste of xDesign. If there's anything specific you want to cover, we can do a workshop specifically for that. And at that, I think we're done for the day. So thanks, everyone, and happy building.